Okay, in this video we are going to talk about lines and how do you find the inclination of a line, what inclination means, how do you find the angle between two lines, and how do you find the distance between a point and a line. Be sure you have your paper set up in Cornell format and write down your essential questions. So what do we already know about lines? Well, since Algebra 1, you have learned about slope-intercept form y equals mx plus b, where the slope of the line is m, which represents your rise over your run, and then the point 0b would be the y-intercept, or where the line crosses the y-axis. So we're not changing this information, we're just going to add a little bit to it. Okay, so if your line is not a horizontal line, it has to intersect the x-axis somewhere. And the angle that you form when your line crosses the x-axis determines the inclination. Okay, so inclination is always measured counterclockwise from the x-axis to the line. Just like in trig, we measured angles counterclockwise. It will be a positive angle measurement, and it will always measure less than pi. Remember, pi is equivalent to 180 degrees. So we are talking about angles from 0 to 180 degrees. And let's look at 4 different kinds of lines. So the first one is a horizontal line. A horizontal line actually does not intersect the x-axis unless it's on the x-axis. So the inclination here is we're going to think about it's not inclining at all. There is no steepness to it at all. So the inclination would be 0 radians or 0 degrees. On the vertical line, remember we said we were going to measure counterclockwise from the x-axis to the line. So what angle is formed when you move from the x-axis to the line? And that would be a 90-degree angle, or pi over 2 if we're working in radians, which most of the time we will. Okay, so in the next picture we have a line that forms an acute angle. Okay, so remember, from the x-axis to the line is our inclination. And then in the last picture, from the x-axis to the line makes an obtuse angle. Now look at the slopes on those last two lines. The acute angle is formed by a line with a positive slope. The obtuse angle is formed by a line with a negative slope. Okay, so these would represent your thetas. Okay, to find the inclination of a line, you are going to use the slope, and the formula is that the slope is equal to the tangent of theta. And if you'll think about it this way, the slope is the change in y over change in x, delta y over delta x. Well, which trig formula do we know that works with y over x? And that would be tangent. So to find the inclination, or that angle between the x-axis and the line, it's going to be tangent of theta equals m. So let's look at an example. Find the inclination of this line. First thing we need is the slope. So we're going to have to put this into slope-intercept form so that we can find the value of m. So I'm going to move the 2x to the other side and then divide by 3. So we end up with y equals negative 2/3 x plus 2. And all we really need from this equation is the slope, which is the coefficient of the x, or negative 2/3. Okay. So I'm going to set up my equation. Tangent of theta equals negative 2/3. Okay, now recall that theta has to be between 0 and pi, which means you're either going to be in the first quadrant or second quadrant, and tangent is negative in quadrant 2. Okay, so we need our answer to be in quadrant 2. If that were positive, then our angle would be in quadrant 1. Okay, 2/3. We can't do that using our hand trick. It's not going to be a special angle, so we're going to have to use the calculator to get the reference angle. So to get the reference angle in our calculator, we have to put in second tangent, or inverse tangent, of 2/3. Don't use the negative when you put it in the calculator to get the reference angle. And when you do this, for this problem, you end up with 0.588. Now that's not your answer. If it had been positive 2/3, that would be the answer. But since it's negative, we have to use our reference angle formulas. And in quadrant 2, our reference angle formula is pi minus the angle. So pi minus 0.588 is approximately 2.554. Okay, be careful with rounding on this. It's best if you keep a lot of decimal places until you get to your final answer. Okay, now let's look at the angle between two lines. So in this picture, I've got two intersecting lines. And when we're talking about the angle between two lines, we are talking about the acute angle formed by the intersection of the lines. Okay, so we're looking for an angle that's less than 90 degrees or less than pi over 2. Okay, so how do you find that angle? Well, one way would be to find the inclination for both lines, and then we would have to subtract to figure out what is the actual angle between. Or we can do this all at once with this formula. Tangent of theta equals absolute value of m2 minus m1 divided by 1 plus m1, m2. m1 and m2 are the slopes of the two lines. It does not matter which order you put them in. The absolute values are there to ensure that we get a positive number because we said our angle had to be acute. It had to be less than 90. So we need a positive value for tangent to make sure that that happens. Okay, so let's look at an example. Find the angle between these two lines. You might need to pause the video. If you would try this, try using the formula, see how far you get, and then start the video again. So the first thing we're going to need are the slopes for the two lines. So we're going to take each line and we're going to find what the slope is. Okay, so to get the y by itself on that one, I can move the y to the other side. And I've got 2x minus 4 equals y. So my slope for this line is 2. Now you can either call that m1 or m2. It does not matter which order because the absolute values are going to take care of the order. So I'm going to call this one m1. Okay, now we're going to do the same thing with the other line. Okay, and again, I'm going to move the 4y to the other side. So 3x minus 12 is equal to negative 4y. Okay, divide by negative 4. Okay, and I'm going to have negative 3/4 x plus 3 equals y. And all I need from this is my slope, which I'm calling m2 because this is the second line, which is negative 3/4. Okay, now let's put those numbers into our formula. So we're going to have tangent of theta is equal to the absolute value of negative 3/4 minus 2 over 1 plus 2 times negative 3/4. Okay, we need to do a little arithmetic here, so we're going to start in the numerator and the denominator, and then we'll see what else we need to do from there. Okay, so tangent of theta is equal to the absolute value. Negative 3/4 minus 2, when you get your common denominator, you're going to have negative 3/4 minus 8/4, which is negative 11/4. Okay. In the denominator, we have 1 plus negative times positive is going to actually be negative, so I'm going to change that from plus to minus. And 2 over 1 times 3 over 4 is 6 over 4, okay, or 3/2. And 1 minus 3/2 is negative 1/2. Okay, complex fraction. How do we get rid of that? Well, we take the denominator and we flip and multiply. So now we're going to have tangent of theta. And since it's negative over negative, that's going to be positive. And the absolute value of a positive is positive, so I'm going to drop those numbers. So 11/4 times 2 over 1. Okay, when you reduce that, you're going to come out with 11 over 2. So tangent theta equals 11 over 2. Okay, now again, 11 over 2 is not a special angle. I can't get the answer using the hand trick, so I'm going to have to use the calculator. So second tangent of 11 over 2, and when you put that in the calculator, you get theta is approximately 1.391 radians. If we were doing this in degrees, that is approximately 80 degrees. And remember, your answers have to come out less than pi over 2. Pi over 2 in decimals was 1.57. Okay, so make sure your answers are in the right range. And on these problems, you won't have to worry about reference angle formulas because the absolute values make sure that this number is positive, which puts us in quadrant 1. Okay, the last thing we're going to talk about is how to find the distance between a point and a line. And the distance between a point and a line is defined as the length of the perpendicular line segment joining the point to the line. The shortest distance from a point to a line is always perpendicular, so we have to look at that perpendicular distance. And again, the formula is given. Okay, so highlight, circle, put a star beside so that you can find it quickly. And this is representing the point x1, y1, and the line ax plus by plus c equals 0. Notice the form that the line is in because we're used to y equals mx plus b form. But for this formula, I need it equal to 0, and I need everything in order. X, then y, then constant. Okay, so in the formula, you'll notice they've basically taken the equation of the line and substituted in the point for x and y. And then we're going to divide by the square root of a squared plus b squared. Okay, so again, let's look at an example. We're going to find the distance between the point 4, 1 and the line y equals 2x plus 1. So if you will pause the video and try this on your own first, and then start it up when you're ready. Okay, remember our formula. The top part is absolute value, and why are we using absolute value? Well, distance, remember, cannot be a negative. On the bottom, since I'm squaring the a and the b, that's guaranteed to come out as a positive, but on the top I need the absolute values to make sure that they're positive. Okay, now the point 4, 1 is my x1, y1, but the way the line is written, I have to do some maneuvering first. So I can't use y equals 2x plus 1 in that form. I need it equal to 0, and I need everything in the right order. So to get it equal to 0, I'm going to move the y over to the other side. So 2x minus y, when I move that, plus 1 equals 0. Okay, now think about your coefficients. The coefficient of x is your a value, so that means a is 2. The coefficient of y is my b value, which is negative 1. And then c is the constant, so c is the positive 1. So let's plug our numbers into our formula. So distance equals the absolute value of 2 times 4. And then b is negative 1, so minus 1 times 1 for y1, plus c, which is 1, over the square root of 2 squared plus negative 1 squared, a squared plus b squared. Okay, so on the top, we're going to have 8 minus 1 plus 1. The minus 1 plus 1 is going to cancel each other out. So we have the absolute value of 8, or 8. And in the denominator, 2 squared plus negative 1 squared is 5. And since that's not a perfect square, we're just going to leave it as square root of 5. You do not have to rationalize unless your directions specifically state, or put it as a decimal unless the directions say that you need a decimal answer. If you have any questions, be sure to contact me either in class, during tutoring, or on Edmodo.